So my name is Chris Kranz. I'm not going to give you a massive intro of my background and what experience I've got and all the rest of it, but I do want to make very, very clear I work for a company called Sysdig. We are a commercial entity. We sell commercial software. One of the things we produced about 3 years ago was we also have a bunch of open source components. One of the things we produced about 3 years ago was a tool called Falco, which was a Sysdig open source project. At the end of last year, it got adopted by the CNCF. So I'm not here to sell you anything. Everything I'm going to talk to you about is our open source stuff, but I just wanted to be very clear about where I'm from, just so you don't think I'm putting a fast foot on. Because it's a smaller crowd, please do ask questions throughout. Don't mind, it's going to be quite good, rather than saving all that for the end of it. A little bit of talk about the history behind Sysdig and Falco and all the sorts of things. The reason why we've got this slide and we've got the specific data points in here is that our CTO, our founder of Sysdig and the Falco toolsets, was the guy behind Wireshark. Hands up who's used or knows Wireshark. Cool, 100%, nice. So yeah, this is kind of the background. He ended up as the CTO at Riverbeds and then left there to create Sysdig. That's where the Falco background comes from. I'll get into more details on that. The rough relationship here is kind of Snort is to Wireshark what Sysdig is to Falco. Falco is to Sysdig. So Snort leverages the output from Wireshark to give you more intelligence. Falco leverages the output from Sysdig to give you more intelligence around the security side of things. So that's the relationship. In terms of my intro being a commercial entity, these are all Sysdig's open source components. So again, none of this is commercial. There's no commercial tie-ins to this stuff. So what is Falco? Falco is a behavioral activity monitor. What we're basically doing is looking for security events and security abnormalities, really, rather than security stuff. So generally that ends up being security stuff, but it is about behavioral abnormalities, if I can talk. To be very clear, it is purely a detection engine. Very similar to a lot of the Kubernetes kind of ecosystem stuff. We're not necessarily opinionated about how to enforce this stuff. We're just opinionated about how to detect this stuff. This means it's fairly easy to plug into whatever processes and stuff you've got and you want to plug it into. I'll give some examples of those as we go through. It has full support for the container and orchestration ecosystem. We talk a lot about Kubernetes these days, from the Cluster API talk just now. Kubernetes is the darling of the industry, but we're actually, the way that Falco works is a very low level. We're looking at system calls, which I'll come on to in a sec. That means that actually we're not just about containers. Containers give us a nice framework because they can encapsulate what's running, and they give us additional metadata, which gives us more context to things. But it's not the only area we can focus on. However, I am just going to talk about containers, the container specifics, and more about Kubernetes and stuff as well. Like I said, Falco is a CNCF Sandbox project. About 2 weeks ago, the team made the request to the CNCF to take it to incubation status. So we're now waiting. They've got some actions for us, which we're going through. So we're just going through that process to see if we can get CNCF adopted as an incubation process. We open to contribution, open to people feeding back into this. There's a couple of slides on exactly how you can get involved in this, even if you're just getting involved as a user of it. To give the analogy, so from a home security perspective, most of us have got door locks. Depending where you live, you might have door sensors. If you live on the ground floor, you might even have bars on your windows. You can tell this slide deck comes through American. So it's all about intrusion prevention. You're keeping people outside of your house. I live in a bungalow and I can't imagine having bars on the windows. The flip side to that is, as much as I live in a bungalow, I also live with teenagers. So occasionally they will leave the front door wide open. So all of my great security in the house, all of that stuff that's protecting people is not going to stop someone getting into the house. Very easy. Obviously they can smash a window or they can just walk through the front door and my teenager leaves it wide open. So we have things inside the house to detect when someone has breached the perimeter, whether that's motion sensors, interior cameras, or in my case, a German Shepherd. This is assuming my German Shepherd hasn't walked out the front door, and also assuming the German Shepherd isn't hiding behind the sofa. If anyone's ever owned a German Shepherd, they look scary and they bark a lot. As soon as they're in trouble, they hide.
There's actually a good video on YouTube about they've simulated burglars coming in, and then they showed reactions of different dogs and their owners, which ones protect them and then which ones sneak out the back door. It's very good.
The one thing I will absolutely credit her for is that if the kids are in the house, she will kill someone. If I'm in the house, she will hide behind me. Something about alphas, I don't know. So, moving us on to IT. We have the perimeter defenses. You've got things like passwords. We've got things like multi-factor authentication. You've got things like, from a container world, you've got things like image scanning. You want to make sure that container is in a good place before you get to anywhere near being deployed. Then within the Kubernetes world, you've got things like admission controllers and network policies. Network policies are a variation of firewalls, just to simplify that down. So I define exactly what I want that container to be able to do. Of course, bad things happen much the same way as they might happen with a home. And while I can't get a digital German Shepherd, I can have a look at other things. We've got things like Kubernetes audit logging, so I can see exactly what someone's doing using the kubectl commands. I've got also system call instrumentation. This is where we kind of go into a little bit more detail from a Falco perspective. Does everyone know what system calls are? Got a couple of people that don't, so I'll just give you a quick view. Basically, any application that runs, any process that runs, has to issue commands to get access to the underlying kernel, the underlying hardware. They do that via system calls. So literally everything that a process does, everything that happens on that system has to go via system calls. Whether that's accessing the network, accessing disk, accessing memory, accessing CPU, two applications accessing each other, all of that is system calls. We don't ingest all of the system calls, we ingest stuff that's of interest, and what's of interest from a security tool will come out in some of the examples. Like I said, we love containers. The nice thing about containers is they should be an isolated process. You have a container, it should do one thing, and it should do one thing in theory well, although a lot of times it doesn't do it particularly well, but it should just do one thing. If you have a MySQL server running a MySQL database running in a container, you should not also be running Postgres. You shouldn't also be running an AD controller and a web server. So it is MySQL container does MySQL only. That means it's really easy to detect abnormalities. What's it doing that it shouldn't be doing? It also makes it really easy to profile those. A MySQL server is going to use port 3306. It's going to use varlib data, I think. It's going to access certain things. It's certainly not going to be writing to etc password. It's not going to be writing to etc hosts. It's not going to be reading from /proc. So you've got these things where you can isolate exactly what it is that it's doing or what it should be doing and create patterns from that, patterns of good behavior, bad behavior. So the architecture, I'll get my digital pointer. So the architecture of Falco, what we generally do is install Falco as a container. It's generally a privileged container. There are ways around doing that as a privileged container, as I've recently found out actually. But by doing it as a privileged container, what you do is you give Falco access to the host. That means it can instrument the kernel itself. By instrumenting the kernel, we either install the Falco or sysdig kernel libraries. That gives us a copy of every single system call. We are not sitting inline. This is one of the key things about us being a detection engine and not a prevention engine. We're taking a copy of all those system calls, feeding them into Falco, the Falco engine. The main reason for that is that it gives us, it minimizes the performance overhead. And that's really core to everything we do at sysdig in general, but also we bake that into the Falco tooling. And that's also why we don't do the inline blocking. So there's no inline decision tree to say, okay, I'm analyzing this system call, or I'm analyzing this pattern, and I'm going to make a decision on that. Clearly that's going to create latency while you make that decision. So we're out of band from that. As I said, this gives us access to all the system calls and all the different containers that are running on there. As you'll see from the slide, you've also got eBPF. eBPF is an open source way of getting system calls out of the kernel. It's becoming fairly widely adopted, and there are many, many other uses of BPF in the IT world. We're looking at it purely from the system call information we get out there and a subset of that system call information to give us our intelligence. More details on the architecture. So like I said, on the kernel side of things, this effectively allows us to bridge the kernel space to user space. So we take that data feed of that system call information, push it up to the Falco engine, which makes these decisions, has a look at this, analyzes the patterns. Sometimes it might actually rebuild several system calls to create a pattern out of that, which we'll get into as well. And this is where you then have the rules library. In addition, I'll come on to this exactly when it was introduced, but Kubernetes introduced the idea of the Kubernetes audit log. So every single command that goes via the Kubernetes API is logged as in the audit log. And the way that works is it pushes that communications out. So you can configure that to send every single log message to something like a SIEM, like Splunk, Elasticsearch. You can send it into something where you script and analyze that, or you can feed that into Falco and or. So you can feed it into, say, Elasticsearch and into Falco. Falco can then analyze the API commands. Again, I'll get into some examples. Like I say, you'll see here that Falco is only generating events. So this is generating events to this alerting engine, and then the alerting engine has a fairly fixed set of kind of outputs. Traditionally, it's been these top 4, so pushing out to syslog file, standout, or shell. We've recently added these 2 extra endpoints, which give us these extra endpoints here. gRPC gives us access to a Falco Go library, so you can kind of interrogate this programmatically, or you can push it out to Prometheus, start creating trending, and so on with Prompt Exporter. And then there's the Sidekick, which I'll explain in a sec. Installation, pretty simple. If you're not running a Kubernetes world, you can just do an apt-get to install it, or a yum install. Of course, as every good security tool should have a curl sudo bash command. Yeah, don't do that. If you don't get the joke, you download the file directly, and then by a sudo command you run that. So the top level privileges, you're running a command you never look down, and you download it straight from the internet. Don't do that. Or of course, Docker pull. And then we've got full instructions there. On Kubernetes, it's either as a Helm chart or as a daemon set. We've also got an operator, which isn't on this for some reason. It's because it was added recently. The full documentation is there. If you install it as a Kubernetes daemon set, the rule set gets deployed as a config map. So that makes it really easy to deploy that across the cluster and manage that across the cluster. And because it's then a daemon set, we override the masters. So if it's a self-provisioned Kubernetes cluster, it will get provisioned onto the master nodes as well. So you can police the master nodes. If it's something like a GKE, EKS, AKS, whatever, so a managed Kubernetes cluster, then obviously you don't have access to the masters, so it just goes with the worker nodes. The other thing in part of the Kubernetes install is we give the Falco engine, we give it access to the Kubernetes API. So we register a read-only service account that allows the Falco engine to talk to Kubernetes in order to get context, such as namespaces, deployments, pods, those sort of things. Additional integrations, you can check in on time just to make sure I'm not going over. So additional integrations, I talked about the Falco operator. We do now have a Falco CTL interface to it, so it's a little bit like that Go library. You can actually interface directly with Falco through a command line, which is quite nice. The Sidekick, which I'll go into more details, the clients I talked about, response engine, again I'll get into details, and the Prompt Exporter. I really wanted to show some screenshots from the Prompt Exporter, but it's so new, and to your comment about Cluster API, the documentation is proper raw, so I couldn't actually get it ready. So I'm hoping to get some screenshots for the next time I show this, but at the moment it's just here's some command lines that you run and magic happens, and of course that magic didn't happen with me. So what does a Falco rule look like? In true Kubernetes style, they're written in YAML format, which means the formatting is a pain in the ass and will cause you problems. But there's basically 3 groupings you have in the YAML file: list, macro, rules. And I always explain this on this slide and then forget that there's actually a next slide that explains it all. So the macros are a grouping of kind of logic. So here I can put in a specific system call, and I can put some operators in there. I can put things like equals to, doesn't equal to, contains, in, things like that. A list, literally just a list, pretty self-explanatory. The rule, this is where the magic happens. This is where you give it a name, description, yada yada, you can read that. The condition is the most important bit. This is where you combine your system call events or your macros or your lists to create some sort of detection condition you're looking for. So the filtering expressions, because we've got that integration with the Docker engine, so Docker's very, very easy to talk to. You just ask Docker for its metadata and it gives you all of it. Kubernetes, because we've given it the service accounts, we've got permissions to talk to Kubernetes as well. Again, we can get context out of that. So it means within the Falco rules, you can start putting things like if it's in this namespace. So you could do something like, I want to whitelist the kube system namespace, but I want to have lots of type rules on my DMZ or my PCI namespace, or even cluster. So you can give it that level of context. The rules are, by the time the Falco engine grabs all those rules, it sticks them in one file and it runs through those. Because of that, you want to be careful on how big that file is. We generally recommend, I think it's around about 100 to 150 rules as a maximum. Just a best practice. All it means is the more rules you have in there, the longer it's going to take to do the detection. So the longer from event to detection is going to happen. And these are security events, you don't want that to be too long. We also filter by the event type. So it means that we can very quickly go through that rules list and figure, does this system call match this event type? Before we even get into the details of the condition, we match that against the event type. The syntax we have on building the expressions comes from the Sysdig world. So if anyone's used Sysdig, inspect, or anything like that, it's all a bit familiar. If you haven't, it gives you an opportunity to go the other way as well. Start with Falco and go back into Sysdig inspect and the other open source tools. If I've got time, I can talk a little bit about Sysdig inspect and things like that if you're interested, but we'll get through Falco first. So you can start seeing the power of this. You've got file descriptors with things like file dots, file name, directory names, so on and so forth. This will also be network connections as a system call. They are a file descriptor of some kind. Obviously processes. You've got system events, and then users and groups. In terms of additional information, you've then got things like the Kubernetes metadata and the Kubernetes audit logs. So this is where you can then start pulling out, someone has requested a new deployment to get run, have a look at the config map of that deployment, have a look at the user that's coming from, so on and so forth. Some quick examples. Very, very simple to say, is a shell running in a container? So here, we're saying it's very easy to define whether it's a container or not. The container is basically defined as not the host. That's straightforward. And then we're saying the process name is bash. Now, anyone who uses Linux will realize there's much more shells than just bash, which is why the default comes with a list of the common bash protocols. So you can do ZSH and CSH and KSH and all those other SHs. But this basically is going to then check to see if someone has opened up a shell within one of your containers. Really powerful, because anyone who's a malicious actor, that's one of the things, that's their kind of the crown jewels of a hack, is being able to get console access. Whether that's a buffer overflow, whether it's a SQL injection, whether it's form injection where you're not policing that form input properly, whatever that looks like, someone gets shell access, pretty much game over for you. So really, really easy for us to detect that. Moving on from there, you've got overwrite system binaries. What would ever do this? Well, the Runc exploit that came out in the last year is exactly what that did. The Runc exploit gave people access to overwrite the Runc libraries. If you don't know what Runc libraries are, it's the fundamental of what containers run from. Effectively, it's the contained process. People can overwrite Runc and overwrite it with something malicious, which then gives them access to every single container I'm doing and all the privileges of those containers. Again, really simple. So, is the file descriptor of a directory in, and here's a list. And is it a write operation? This is actually a macro. So we're actually pulling out the macros that define what a write looks like. And again, you can get that in the defaults.
Are these intercepted at invocation, or is it further into the call? So if that call failed anyway, would it still be traced?
No. So if you had something like SE Linux or Setcomp that was blocking these, we wouldn't see them because they actually didn't generate a system call. Yeah. We're seeing these as system calls. If anything got through, it would have generated a successful system call, and then we'd pick up on that. And we're async, so we're taking that feed. We may be half a second, a fraction of a second behind that call being made, but we'll pick that up. But if it's blocked, like I say, usually blocked with something like SE Linux or Setcomp, we won't see that because it was blocked.
Yeah.
So we don't see that command being trying to be executed. The interesting thing is on the Sysdig side of things, you've got the ability to inspect those system calls, and what you quickly realise is the very async nature of Linux. So commands don't get executed in the order that you think they are when you type them. Not always. But we see them in the order they come through as system calls. Sometimes confusing. We can detect when a namespace has been changed. So again, a common exploit that people try and do is they have a certain privilege or they're stuck in a certain namespace from their container runtime. This allows them to switch out of that namespace. Obviously, this is what Docker does by itself, and also the Sysdig agent also does some of this stuff as well. And if you're also non-device files written to /dev, common practice of malware, go and hide something in dev. No one looks in dev, that's just devices. So let's go hide my malware in dev and just call it something that is innocuous. So again, very, very simple to look at. Although this looks a little bit more complicated, breaking it down, it's might be easier. You've got an event type is a create. The event argument flags are or the event arguments contain a create variable. The process name is not a kind of a known, I actually don't know what that is, but kind of a known entity that happens within these spaces. The file descriptor directory is in /dev, but the file descriptor name is not dev null. So lots of people write to dev null, and that's perfectly fine. That's regular. I output all my logs to dev null. So that's fine. Writing to dev null is not a problem, but writing anything else is not. Does that make sense? Often when we show, so often I just because of the way I demo things in the commercial product, I end up pulling up a full list of Falco rules, and it does look quite overwhelming. So breaking them down like this hopefully makes it a little easier. I won't go into too much detail on this because some of this is kind of becoming a little bit irrelevant with some of the new engines we've built in. But I'll talk a little bit futures here. So at the moment, the Falco engine handles the detection and also the output. So some of this output here is actually written into the Falco engine itself. So all of this is written into the Falco engine itself. So it means it's having to do some translation. Remember what I said before about containers? They should do one thing. So we're adding components into Falco that aren't really that one thing. You could argue they kind of are, but so what we're looking at doing, what we're investigating at the moment is taking all of this output and have it processed somewhere else. Which is where you'll see me talk a little bit about the Sidekick. The Sidekick is still in beta, we're still playing around with that idea, but you'll see that kind of idea going out. The other advantage to that is that then you have a fleet of Falco instances, and you can have one place that handles all of that message translation. So it makes it a little bit more efficient. Actually, probably makes it a lot more efficient. You'd also notice that one of the things you can do is direct shell output. In this scenario, we're sending an email, which is nice and simple, so long as you've got SMTP configured on the hosts. You could do a Docker kill at that point. Now, within caution, because if you've got that as a false positive, you could be killing things left, right, and centre. But you could, in theory, do a Docker kill as an problem. Like I said, introducing the Sidekick, which is something that's come out quite recently. So this is where we've then added a bunch of external integrations. That means that we're by doing this, we're doing some translation to that message. So we take that Falco message in its fairly raw format, we can process it, reorder it, put it into, package it into something else, and then pipe it out to one of these other integrations. And this is where you can actually, it's really obvious that we've got our open source team, and this is a CNCF project, because Sysdig commercial tooling isn't on that list, but Datadog, who are definitely one of our competition, are on that list. So we do treat Falco very much as this isn't our project anymore, this is CNCF, we will continue supporting it. Whoever wants to integrate with that. So, again, going into a bit more detail of the Falco rule. Here we can see we've got something is happening that's executing a program. So the event is of type executing. The container image starts with node. So here we're looking at the Docker metadata to see where the image starts from. And then the process name is not equal to node. So very simple, someone's come along and they've renamed their malicious Python web server as a node server so it gets in under our radar. We can straight away see, yeah, that's not running node. Now what's the problem with this, and someone pointed this out to me the other day, is that you need to be careful on the rule syntax, because what this doesn't do, if you call something, if you've got a bunch of demo applications and you come along and say, oh, this isn't my demo, so I'm going to call it no demo. It's going to match this pattern because it starts with node. So, you know, you've got lots of power in this, but as if everyone's ever read your regex, you know just how dangerous regex can be. So the Kubernetes audit events, they were introduced in the K8s 1.11. Like I say, they are a push technology, so it's not something you scrape. You have to configure Kubernetes to do this. I think this has been rolled out across most of the cloud providers as well now. So I believe you can get this from EKS, AKS, and GKE, as well as others, IKS and everyone else. It comes out in standard JSON format, which looks something like that. So it gives us a lot of information about where this comes from, what the user type, what type of data is in there, and there is also a raw object that gives us actually the contents of that. What we try and do is we try and pull some of that information out to top level objects for us to be treated with. So you've got this idea of these KA objects here, so you can address things directly rather than having to browse through the JSON data. We do also give you access to the JSON data. So if there's something that we didn't think was important, but you want to interrogate, you can still do that via the JEvent value. To give an example, the previous Falco example didn't use macros or lists. This one does use macros. It's a little bit more lines on the screen. But basically we've got the rule down the bottom. The request coming in has a config map. So we can see that's a config map. This config map is a macro. And here you can see the resource type basically has a config map in it. So pretty straightforward. It is a modify. Again, we can see this is a macro. The modify is create, update, or patch. A couple of different ways you can create new objects or edit objects within Kubernetes. It's not just about creating. If you edit something, you could also inject the config map at that point. And then it contains private credentials. And here, fairly simple kind of keyword matching. What we're looking for here is someone who's stood up or edited a deployment or anything really that has a config map attached to it that then has some sort of definition of having private credentials. We don't want people injecting clear text credentials into Kubernetes at all. If you must use Kubernetes secrets, best case use something like HashiCorp Bot or other secret management solutions. This is less kind of relevant to Kubernetes because you'll end up putting it in the config map anyway, but you can, in the raw format, you can have multiple rule sets in there. This is useful if you might have a couple of different teams where you have, here's my universal rule set, and then for my dev team, you can have your rules. For my PCI team, you have the different set of rules. Everyone has the default rules, and then you have different rule sets on top of that. Workflow, I've given this slide 3 times now. I keep forgetting to update. I'm supposed to say to an events hub. I get to the end of the slide and I'm like, phew, I've delivered that, and I go home and go to sleep. So you have the Falco engine which generates the activity. This Falco event will publish it to an event or a pub sub service. That pub sub service does something with it. It's going to stick in the queue. The nice thing about having some sort of pub sub service is you can stick different queues involved in there. So that means you can have different queues for different types of events. You can have a all events that goes off to your SIEM, so just dumps everything. And then maybe you have a critical alerts, which goes off to some workflow that takes action for that, and which is the action service. So examples of this using the Sidekick. So you take that event feed, the Falco Sidekick is written in Go, hence the little icon, nice little icon that someone in the community did for us. That feeds into an event handler, which is the Sidekick doing that, and you can push that out to something. Your execution here, so if it goes out to Datadog, you can go out to the website. If it goes to Slack, it can post, go at here on general. Or you can use something like Lambda and execute a reaction from that. Using a Lambda function, which I'll show you some examples of, you can then use that to interact with the Kubernetes platform. Lambda's great because it's just, you can do anything with it really, pretty much. So you can then operate an action out the back of that, kill a pods, kill an entire cluster. One of my colleagues is playing with the workflow where you can have the execution of, when you see certain traffic, you can effectively isolate that off. So you can send it to a honeypot service. So if you see certain detections, feed it into a workflow, start streaming that particular traffic out to a honeypot service so you can analyze it more. Or feed it off to dead now, something like that. Chucking some specific technologies into here. So this is leveraging the CNCF community. So using Falco to the event detection, feeding it into NATS. NATS being the pub sub service here, has multiple topics as they call them. Everyone calls it something slightly different, so I have to read my slides. So NATS using the topic service where you have those different topics for those different event types. Feeds into Kubeless. Kubeless being the function service here, which then takes options. In this case, going off and doing something like a kill pod. Exactly the same, but using Amazon services. So now we're dropping in SNS to replace NAT, and we're using Lambda to replace Kubernetes. The nice thing about leveraging functions here is functions are, just basics of what functions are. It means they're small and usable. You can have multiple functions to do multiple different things. So based on the different topics you have within this workflow, you can trigger off different functions to take different actions. Because those functions are small, reusable components, literally the reason we have functions, it just makes them really, really easy to make them modular. You lots of clever things with those. Like I say, the possibilities are vast there. We haven't got around to thinking through those all yet in our tech marketing team and our open source team, but there are lots of different options you can think of in doing that.
So is this functions as a service?
It plugs into functions as a service, yes. Another popular one, and I was talking to someone earlier today actually, maybe it was, I think it was you, someone else. So I've had lots of conversations and not enough sleep. I've got a 1-year-old if you're interested in why I haven't enough sleep. So using it as a SIEM, and the reason I'm a big fan of this is, so I'll go through the workflow first. So Falco, like I said, can publish things as standard apps. That means that Fluentd is just going to pick it up natively. Fluentd will then chuck it in Elasticsearch, use Kibana to start visualizing that. Now the reason I like this is because, so traditionally when we have security, you take your application, you put it in production, and then security comes along and puts a cage around it. And then things start breaking, you have no idea why, because for security won't tell you what they've done, because that would be a security issue. They actually told you what security does. So the idea of pushing security left is making security more of a responsibility of the dev teams. I really like this from an education point of view, because if I start trending Falco activity within something like Kibana, I can then start showing you what good and what bad is. We can have a look at this diagram, and you might want to say, well, all of this stuff here is relatively harmless. You're doing stuff you shouldn't be. You know what, it's not that bad. This bit, really, really dangerous. Please stop doing that straight away. What I've not done there is I've stopped you from doing that because you're doing something really stupid, and I'm not going to tell you what you were doing. What I'm doing there is I'm giving people visualization in their tools. Most people are already using things like Kibana, and I'm giving them a bit of education. So as you go through the different life cycle, you start with dev. I'm going to start saying, that's really, really silly, but dev, you need to have a playground. In your sandbox environments, I'm going to let you do silly things. You can download stuff straight from the internet and execute it as root without checking it first. That's fine, because I've isolated you. But try to do that in production, I'm going to destroy your containers. You're not going to be able to do that. But making sure that they know why that is and how that is, you push that education around. You get people to start thinking about it, so it's not a surprise. It's like, yeah, you're in production, I've killed everything you tried. Probably rattle through this, but so Falco is an open source tool. I keep saying we, and I shouldn't. It's just because of the background of assisting Falco. It is a CNCF project. We are part of the team, kind of steering that committee. There is a commercial entity behind paying the people in our open source team. They are an open source team. I actually pretty much get no access to them. So if you want to get involved, the simplest thing to do is write rules. The team behind NPM, so the Node.js libraries, they wrote a whole bunch of tools that profiled a bunch of kind of NPM stuff, and they fed it back into the community. We've got a whole bunch of, you can see there from the link, a whole bunch of profiles and stuff that gets fed into things. So there are various events, as you saw from the diagram before. We've got maybe 15 different event streams that are in there today, or integrations. There's a whole bunch of others that can be added to there. Fairly straightforward to adding into those. The other thing, in theory, we've not really proven this, or not really had a use case to do this yet. We've got two sources of data today: system calls, or BPF, and Kubernetes audit logs. There's nothing stopping us from taking event streams from other locations. It could be that actually I was having a conversation earlier in the week about writing application trace points as security incidents. So actually putting more data into Falco. As long as there's a use case to it, it makes sense to add that. It is in theory, Falco can be the full kind of security detection engine for your container workloads. When I say full, I just mean everything's thrown in it, not that it's got 100%. Be very careful about security at 100%. Those two things aren't compatible. And then this is some of the community stuff we've got. We do have a public site repo. We've got a bunch of stuff on GitHub, and the documentation is a lot better than it used to be, but it can still, as all documentation can be improved.
You are sharing these slides, aren't you?
Sorry?
You are sharing these slides, aren't you? Sharing the slides.
Yeah.
That'd be good.
Yeah.
Thank you.
And that's the slides. I will check if there's any questions. If there's no questions, I'll show you a couple of the rules from the rules libraries. So, any questions?
I have a question. I think my question is more about if you have a bunch of rules for, so I'm trying to say like how exactly, which is actually going to trigger the first action. For example, you have a bunch of rules and it matches the same container or set of containers. How exactly that rule is going to be applied? Is there any priority to it? Can it be weighted, or like this rule is more credible than the other? Is there any system to do that?
It's a good question, and I would have to check on the answer. So I will give you an answer, but my caveat to that answer is it's probably not the right answer.
An
So-
intuitive answer?
Yeah. At least I caveat myself. So we've got this YAML definition. I believe it reads a .m. So it's basically the first rule that comes across is good executing that.
Right, so it's based like on the YAML configuration.
So regardless, even though you've got two rules, one may be more permissive further up and the second one may be more or less permissive further down, I think we'll hit the first one first, and then we'll stop processing.
It stops processing at the first rule file.
Yeah. So we won't try and apply multiple rules to the same. I might be wrong there. The reason I might be wrong there is because I'm just trying to relay this. So I like I said before, I work with the commercial tools, and in our commercial tool, we definitely flag multiple rules if you trigger those. So I think it might flag all of them.
Right. And I think another question I had, you mentioned that we can trigger a Lambda function, which pretty much means we have to use an external service, which is fine. My question was, is there any roadmap to use tools like Knative to actually still ingrain within the cluster rather than outside?
Definitely. So if I go back to, this is purely using Kubernetes, CNCF functions. So this NATS cluster could be in your Kubernetes cluster, this kubeless could be running in your Kubernetes cluster. You could remove those and put Knative into that. You can put this RabbitMQ into here as well.
So it's like quite pluggable into...
No, absolutely. So all we're feeding here, we've got a translation engine here, which publishes a message into whatever format you want, RabbitMQ, Kafka, NATS, any technology you want. It's this subscription process that then allows plugging into the functions. You could take this out completely and not have the queuing engine, so actually just have the output from Falco go straight into a function. The main advantage to having this topics queue in the middle is you get to categorize things in that process. So if you didn't do this, you'd have to put some logic, and you may end up with functions calling functions, which is absolutely fine as well, something that a lot of people do in Lambda. This is just a convenient way of handling that. So in this workflow, you do have to take, and I guess to your point, or extending your point, this adds latency. So there's an operational overhead to pushing this into NATS, getting kubeless to pick up on it, getting kubeless to function that, to operate that function. It should be pretty quick, but you might be waiting a second, 2 seconds. If it's a really busy system, you could be waiting 5 seconds. The other thing on that is possibly and this is for everyone to decide, this isn't me saying, this is just an idea, is to consider the fault domains of that. So if you have all this logic in the same cluster, you're effectively getting the cluster to protect itself. So if the cluster is fundamentally compromised, you're relying on its protection mechanism on something that might be compromised. So by pushing this out to a second cluster or to a separate service, yes, you're adding latency, yes, you're adding external dependencies, but you're also minimizing the potential fault domain. But that, like I say, that's for everyone to analyze their own risk on that, to have a look at whether that's a realistic risk we want to look into, or the convenience of bundling it into the same cluster outweighs the potential risk, which we're going to mediate with other things.
It's probably a bit too deep for this sort of level, but I was just wondering about the resilience of that Falco component. So is it able to be a replica set as well? So you can have multiple instances processing the same rule set for the same node?
No, I mean you could try, but there's nothing that would get the two instances to talk to each other, so you could get twice the traffic.
Yeah.
We've had this question before quite a few times, both in the open source and the commercial tooling, and while yes, I can kind of see the benefit of doing that, the flip side to that is Kubernetes handles those failures and the recoveries of those. Your you're adding in additional resilience for something that doesn't need it. I don't have 2 systemds, I don't have 2 Docker daemons, I don't have 2 lots of Kubernetes system, Kubernetes DNS per service. They're designed for failures.
And I suppose the focus is single pod sort of rule sets, is it? So it's sort of like rule sets applied to single pods, they don't apply across pods. So if you had like a clustered SQL, MySQL or something like that, you would have to monitor it as an individual pod.
No, not at all. So, so you can, because we put in the metadata, you can say, okay, this namespace or this deployment type is MySQL. Yes. Apply this, and then you can say if my communication between my 2 MySQL nodes is this, that's fine. If they're communicating outside of the SQL cluster, so if someone's trying to replicate, I've got my 3-node cluster, and someone's trying to add in a 4th node that hasn't been authenticated, flag that as an alert.
Hopefully.
Yeah, so there's a lot of ways you can extend that and add a lot of intelligence into it. It's one of those things that I'm really keen on people's feedback. So we try and keep the slide deck relatively high level in terms of the rules, just to be not too overwhelming. But the rules are hugely powerful, so you can add lots and lots of detail into there. One of our customers on the commercial side, we still use the Falco engine, so that's why I keep talking about that. So one of our customers actually dynamically writes rules. They take the kind of known entities. So take the example of cluster API, for example. You're constantly deploying stuff. You don't know the IP addresses. You don't know the entities of them until they're created. So at that point, you actually feed that into the rules engine to create whitelisting or blacklisting of random entities or dynamic entities. So that's something you can do as well. You can programmatically create the rules. One of the reasons we created things like the Falco Go library and the Falco CTL, so you can actually programmatically talk to the configuration to the cluster, well, not cluster, the Falco runtime.
Yeah. Do you still submit YAML to that API?
I believe so, yes.
Cool. I'll let you move on. I've got
Cool.
other questions, but we can go back to those later.
No worries. So I was just going to give, just show you, this is, all I'm doing here is browsing through the Falco rules library. So just to give you a couple of examples of rules, you can have things like, you can read the rules for yourselves in detail, but just give you a couple of examples. I'll flip through some of these. So you've got disallowed SSH connections. So this is where you can have known bastion hosts or known admin hosts. Anything that comes from something that isn't known, you can start flagging them up. To your point about MySQL cluster, so if I bake this into this particular rule, what I can do is I can say if there's an outbound, I'm not sure what MySQL talks, what port MySQL talks on for clustering. It's been a while. I just know 3306. So if one of your MySQL servers is making an outbound connection to something that's an untrusted MySQL host, flag that up as well. This is also useful for things like if my MySQL server is making any outbound connections to the internet, why the hell does MySQL make connections? If my RabbitMQ server is spawning processes, things like that, you can start doing that at kind of a network level. Now, your network enforcement should absolutely be at the CNI or the service mesh layer, or your security groups, your cloud services. This is belt and braces, so this is an additional line of defense. So I'm putting my action enforcement where it should be, which is your firewalls, whether that's software firewalls in a CNI, service mesh, or in security groups. What I'm doing here is checking. So one of the downsides of external firewalls is they don't check east-west traffic. So I'm not in my security group. I'm not necessarily going to see if I'm not actually at all going to see if 2 containers on the same host are talking to each other. In my CNI or service mesh configuration, I should see that. But this is then just policing that to make sure I'm not seeing that. One of the great things about Kubernetes is it's all defined. So my devs define what my configuration is going to be. The downsides of Kubernetes is that it's defined by the devs. Not all devs know what they're doing. In the nicest possible way, this is just a brand new world. I've never had to go to a dev team and say, tell me exactly what ports you're running. Tell me exactly what processes you're running. Tell me exactly how that operates. Most of the time, a dev comes along and says, this. If I go to them with a report, say, this is how your app operates, they're like, oh, I didn't know. So part of this, again, is that education. A lot of people will request things that they don't really need, they just think they need. Work on my laptop. For some of the Kubernetes audit events, you've got, this is where we're pulling in from the API logs. So here we can check for disallowed users. We can check for things like, you can blacklist pods, or you can do things like creating privileged pods, as you can see here. You can extend this beyond that into things like sensitive mounts and so on. This is where one of the, I think the Runtime exploit came from mounting things you don't have permission to, but you've got the ability to do it. Okay, cool. So you can get quite detailed with this. Now again, there are, in theory, there's controls to protect all this stuff already, but it's making sure it's got that additional level of policing. And some things actually circumvent that control. Like some of the Kubernetes exploits we've had are people are using Kubernetes the way it should be used, but then a vulnerability comes out, an exploit comes out, and you just can't detect that. That's kind of Falco's that almost like that last line of defense. We call it the 0-day kind of capturing those. Any other questions? If not, what I'll quickly do is show you Sysdig Inspect, just because I really like Sysdig Inspect. So it's still open source, not showing anything commercial here. What you can do with Sysdig open source tools is take a capture. A capture is a copy of all the system calls for a period of time. So in theory, what you can do is you can actually plug Falco into this. So you can say Falco season events, now get Sysdig to capture every single system call for a short period of time. Its outputs a system capture. And remember, our founder Loris came from Wireshark, and Wireshark outputs PCAPs, and this file happens to be called an SCAP. Didn't win any prizes for naming conventions. So instead of a packet capture, it's a system capture. So here you can see everything that happens. Now, if you've got a logging tool, you've got this section. You'll have a list of your HTTP requests and errors and your log files. If you've got network monitoring, you'll have this section. With Sysdig captures, you've got all of that in one place. In terms of the level of detail, I can drill into the commands that were executed. I can see exactly what commands were ordered, which is fine. I've probably got this pushed away somewhere else. But I can see one of these commands was a tarball. I can open that tarball and I can see what files were written out of that tarball. From that, I can see I can rebuild the IO streams of that file. Rebuilding the IO streams of that file gives me the file contents.
Wow.
So I can now see exactly what it's done there. Now I'm not storing the entire file contents. You'll see that's truncated. It's the default's 4K. We've configured this particular capture to be 16K. It's customizable. So that's great from a security perspective. It's also really powerful from a troubleshooting perspective. So I can look at accessed files. In my accessed files, I have config data. I can see, with my application using htaccess, and is that potentially what the source of my problem was? If I see an error being generated in my HTTP errors log, I can cross-reference that back to file access of htaccess, of NSSwitch, etc hosts. I can start tracking those errors through. So it's a really powerful forensic kind of troubleshooting tool. I just want to quickly show you that because it's another one of our open source tools, which I really like playing with this because it's hugely powerful, and I'm just because it's the end of the session, it's kind of show you that quickly.
Do you get many people using this for QA, like test processes?
No, it's not that I'm aware of.
So like more low-level system sort of test processing where you need to sort of write a certain amount of files.
I've not seen it as that use case, but it'd be interesting to talk to you more about that. So I've not heard that.
I've just come up with the idea.
There we go. Patented.
Yeah, exactly. Cool. I think.
Cool. Well, we're around for the rest of the day. The slides will be shared. What I might try and do is just quickly add a couple more links to some of this open source stuff as well, if people are interested in this. I'm around for the rest of the day.
And also, we did talk about over email about maybe getting you down to do a workshop.
Mm-hmm.
I've got your video now.
That's fine. So our open source team have written a proper hands-on workshop where we actually go through this. We give you a bunch of example apps that are purposely broken or teach you how to purposely break things. We walk you through the workshop. That workshop can be 1, 2 or 3 months.
Yeah, so you signed up for that.
So that's going to be put up as well as the slides.
Fingers crossed, yeah. So
Okay.
assume everything went well. So, yeah. Oh yes. Thanks very much,
Cool.
Chris.
Thank you very much.
Awesome. Yeah,